All right, chemistry students. This is our next part of our reactions unit, and this is the second part of the notes. We're going to talk today all about balancing chemical equations. Now, you should have already done the balancing act lab. This was a lab simulation. It's online. If you haven't done this yet, do this first. This is going to guide you through the whole process. It'll make it really straightforward, I think, and you get to kind of discover how this all works on your own. Once you've done this, all these notes should be review. So do that first. And then we're going to talk a little bit about balancing chemical equations. I didn't leave you a lot of space here. Sorry about that. I do actually have some stuff in the notes, but you don't necessarily have to write it all down. Otherwise, you can find a place to write it. So let's dive in. Actually, let me show you one other thing before that. There's also a video. No, let's do the notes first and then I'll show you the video. It's good. Okay, so here are the notes. All right. So in the universe, there are these laws, and these are laws with a capital L. These are observations that scientists have made that seem to be extremely consistent across the whole universe. And one of these very important ones is the law of conservation of mass, which means basically that matter can neither be created nor destroyed. So at the beginning of a reaction, from the beginning to the end, we can't have lost or gained any matter. In order to make sure when we write chemical reactions, we have to make sure that they obey that law, meaning there have to be the same number of each element on each side of the reaction. So to do this, it's kind of similar in a way, mathematically and I guess conceptually, to writing ionic compounds. But this time we're going to use coefficients in front of chemical species to show that ratio, to make sure that they're the same on both sides. So taking our example from earlier, this is the exact same reaction that we talked about in chemical equations. Calcium chloride and sodium sulfate produce calcium sulfate and sodium chloride. I got rid of the little states of matter in parentheses afterwards, just because I wanted to kind of clean it up a little, make it look a little nicer. If you remember, it looked like this before, but it's the exact same equation. Okay, so let's dive right in and let's do it. So the way that I do this is I want to keep track of how many elements there are on both sides. So looking at this, I can see that there's 1 calcium and 2 chlorines. It's kind of easier to see this way on the reactant side. And then there are 2 sodiums and 1 sulfate. You could think of this as sulfur, 1 sulfur and 4 oxygens. Doesn't really matter. It will work either way. On the reactant product side, so these are the reactants. On the product side, we've got 1 calcium and 1 sulfate, or 1 sulfur and 4 oxygens. So far this seems balanced. It seems like they're the same on both sides. So 1 calcium, 1 calcium, 1 sulfur, 1 sulfur, 4 oxygens, 4 oxygens. Looks good so far. On this side of the equation, the products though, right now, there's only 1 sodium and 1 chlorine. So this is not balanced as it is right now. Right now, we don't have any numbers written in, which we can assume if there's nothing written, it's just a 1. So we can't change any of the species. They are what they are, but we can change the ratio. So if we add another sodium chloride, it looks like that should take care of the problem. So this is what the balanced chemical equation looks like. It shows 1 calcium chloride, 1 sodium sulfate, 1 calcium sulfate, and 2 sodium chlorides. You notice that we haven't changed anything about the reaction. None of the species have changed. The only thing that's changed is their ratios. So this 2 here is the coefficient that I talked about right here. And that 2 means that there's 2 of whatever is afterwards. So it means that there are 2 sodium chlorides, which are here, which means that there are 2 sodiums, 1, 2, and 2 chlorides, 1, 2. This balances because this side of the reaction also has 2 chlorides and 2 sodiums. So when I double check these in my head, I go across and I make sure, okay, there's 1 calcium, 1 calcium, 2 chlorines, yep, 2 chlorines, 2 sodiums, yep, 2 sodiums, and 1 sulfate and 1 sulfate, or one sulfur, one sulfur, four oxygen, four oxygen. So all of the elements are balanced and we have a balanced chemical equation. So this is what we're going to work on for a little bit, is just balancing chemical equations. So let me show you what that will look like for you. You all are now able to do the first page of your unit packet. This is all balancing chemical equations. So your job is just to put numbers in all these blank spots. If you want to put a 1 to represent only one, that's fine. If you want to leave it blank, that's also fine. I have a habit of leaving it blank, but you might want to put numbers in. It's kind of up to you. I will have an answer key for this pretty soon. It just might take me a little bit of time. I'm actually recording this like before the October break, so you guys haven't actually done it yet. I'll have it done by then. Unit 2, or page 2, I'm sorry. Page 2 you also can do. Now, page 2 is going to require you to write the whole reactions first. So these are in Word form. You're going to need to convert them into like equation form like that. So this is an extra step that you can start working on. Reaction type we haven't learned about yet. That's the next thing we're going to learn. So for right now, you can leave those blank, but you can come back later and redo those. And you're going to see as we continue on, it's pretty much the same thing over and over again. Reaction type, balancing, that sort of thing. Okay, let me show you some videos. There is one video I really want you to watch just because it's interesting and I think will help you with some concepts. So if we go to my Chemistry Unit 5 reactions playlist, this one right here, this law of conservation of mass. I'm going to leave a link for this one. Please watch this one. It's only 4.5 minutes long. It won't take you long, and it's very, very good. If you need extra help, we've got Tyler DeWitt's videos on balancing chemical equations are right here. Let me just make sure. Yep, those are the only ones. And if you need help on page 2, so on this one, with the whole how do I write these out as equations, you can watch this video on how to write chemical equations from word descriptions. I might go over one of these as an example, probably in class. That would be good. But this video is a little bit long, but it's very, very helpful. So those are good. Oh, and from last time, remember how we talked about diatomic elements, the Hofbrinkels? These are 2 videos all about that. In fact, there's one video called Super Common Mistake Diatomic Elements. It is a super, 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 super common mistake. It happens constantly, all the time. So I'm going to mention diatomic elements all the time. If you ever see oxygen, hydrogen, oxygen, bromine, iodine, chlorine, fluorine, or nitrogen listed by themselves, then you know that you have to write a Hofbrinkel. And you have to write a diatomic. I'll actually even show you a quick example of that because I just saw one. Okay. So actually, I'll do one of these real quick for you. Why not? That sounds great. Let's do number 1 on page 2. So if we have to write the equation from this description, we've got hydrogen, chlorine, and hydrogen chloride. So what we need to do here is write each of these as, these are the names, we need the formulas. So hydrogen is H. We can look in our periodic table. It's right here, but it's got one of these little stars next to it, so we know it's a Hofbrinkel. So you can't just write H, you have to write 2. After it has this G that represents gas, so let's include that as well, because we might as well. Okay, so the next thing is chlorine. Chlorine is Cl. It is right here. Oh, it's also a Hofbrinkel. Better put a 2. And it's a gas. Okay, so we're just translating these from words into formulas, from names into formulas. And finally, hydrogen chloride. So hydrogen chloride is H. That has a +1 charge. Cl has a -1 charge. So HCl is the formula, and that's also a gas. So for me, writing the formulas is really easy. Writing an ionic formula, like I can just do it. I've been doing this for longer than most of you have been alive. But it's okay if it takes you a little bit longer, but it really shouldn't be very difficult for you at this point. You've had a lot of time to practice with it. So if writing ionic formulas like hydrogen chloride or covalent formulas like carbon dioxide, magnesium chlorate, magnesium chloride. You can see this stuff isn't going away and we're adding more complications. If you make a mistake writing these ionic formulas, it's really going to affect your answers, and it's going to be really hard to succeed. So keep practicing those. If you need more help, let me know and we can sign up. We can sign up for like a tutoring. I'll set you up with like a tutoring session. We'll figure out a good time to do that, and that will happen. Okay, so writing the formulas, I got distracted. Let's finish this off. Let's balance it. So right now we've got 2 hydrogens in the reactants and we only have 1 in the products. So that's a problem. And we've got 2 chlorines in the reactants and only 1 in the products. So if we just put a 2 in front of here, that should balance the whole thing. You'll notice I didn't put 1s in front of these. I have a tendency to not, but if you want to go ahead and put a 1, in front of each of those, you are welcome to do so, but you certainly don't have to. It's not really my thing, but go for it. Also, 1s and L's can get really confusing, and I's sometimes, so it's just easier not to. Anyway, that is the balanced chemical equation. The reaction type we're going to learn about later. So we'll do that then. All right. Hopefully that worked out for all of you, and it makes sense. We're going to keep practicing these, and we're going to keep learning more about chemical reactions. I will see you in the next set of notes when we talk about the 5 types of reactions.